Hello students, welcome back to Husky Math. Today we will continue our integration by parts. This is the part 2 of this particular topic. So let's continue. Question 1. Integrate e to the power x into 1 over x minus 1 over x square dx. So before doing question number 1, there's one type of integral where the function is e to the power x into f of x plus f dash of x dx. If I integrate this function with respect to x, then let us see what will happen here. So first let us open this bracket, then we will have integration of e to the power x f of x dx plus integration of e to the power x f dash of x dx. Here one thing we have to note that this f dash of x is the derivative of this function f of x. Now let us use integration by parts in this particular first term. So evaluating this first term with using integration by parts, then we will have first function into integration of second minus integration of ddx of first function into integration of second dx dx plus integration of e to the power x f dash of x dx. So this equals to fx integration of e to the power x is e to the power x minus, here the derivative of f of x can be written as f dash of x into integration of e to the power x is e to the power x dx plus integration of e to the power x f dash of x dx. Now if you notice, then here these two terms are same but opposite in sign. That means they will simplify to 0, and hence my final answer will only be e to the power x f of x. So that means if my integral is of the type e to the power x f of x plus f dash of x dx, then this can be directly written as e to the power x f of x plus constant of integration. So here in question number 1, we can see that 1 over x square is the derivative of 1 over x. So here if you notice that, then if I consider this as f of x, then f of x will be 1 over x, and if I differentiate both sides with respect to x, then I'll have f dash of x will be equal to minus 1 over x square. That means this second term is my f dash of x. Now this particular question is in the form of this type. That means integration of e to the power x 1 by x minus 1 over x square dx is equal to e to the power x. From here you can see that the answer is e to the power x into fx plus c. So here it will be e to the power x, and my function fx is 1 by x plus c. So this is the answer for this question. Question number 2. Integration of e to the power x into sine inverse of x plus 1 over square root of 1 minus x square. So here also, if you see, then sine inverse x, if I consider it as f of x, then the derivative of it is 1 over square root of 1 minus x square. That means if this is my f of x, then this is my f dash of x. Now again, this is in the form of this, hence I will write directly answer that will be e to the power x into fx, that is sine inverse of x plus c. So this is the answer for this question. Question 3. Evaluate 2 plus sine 2x over 1 plus cos 2x e to the power x dx. So before integrating, let us modify the given function. Then here equals to integration of 2 plus sine 2x is 2 sine x cos x divided by 1 plus cos 2x can be written as 2 cos square of x e to the power x dx. So if I take out 2 common, then I'll have 1 plus sine x cos x divided by cos square x. The 2 from the numerator and denominator got cancelled, e to the power x dx. Now let us separate the denominator, then we will have 1 by cos square x plus sin x cos x by cos square x into e to the power x dx. So it equals to integration of, let us write e to the power x at first. Now 1 by cos square x is sec square x plus here cos x and this cos square x got cancelled. So sine over cos is again tan dx. Now here sec square x is the derivative of tan x. So if I consider this to be f of x, this is my f dash of x, and outside we can see that this term is getting multiplied with e to the power x. Now this is of the type given here. So we can directly write the answer as e to the power x into fx plus c. So my answer for this question will be e to the power x into fx is tan x plus c. Question 4. Integration of x over x plus 1 whole square e to the power x dx. So here my function is x. Let us add 1 and subtract 1. Add the numerator divided by x plus 1 whole square into e to the power x dx. Now let us separate the denominator with these two terms, that is x plus 1 and 1. So here this equals to integration of x plus 1 over x plus 1 whole square minus 1 over x plus 1 whole square, everything into e to the power x dx. So here x plus 1 and this square got cancelled. So this equals to, let us write e to the power x at first, and inside the bracket we will have 1 by x plus of 1 minus 1 by x plus of 1 whole square dx. Now let me consider this term to be f of x. So if I consider this as f of x, then let us differentiate this function. Then we will have f dash of x equals to ddx of 1 by x is minus 1 by x square into, by chain rule, the derivative of x plus 1 is 1. Hence my f dash of x is equal to minus 1 by x plus 1 whole square. That means the second term here, that is minus 1 over x plus 1 whole square, is my f dash of x. Now again this is in the type mentioned here. So the answer for this question will be e to the power x into fx, that is 1 by x plus of 1 plus c. Question 5. Integration of 1 over log x minus 1 over log x whole square dx. Here let us substitute log x equals to t. Then x will be equal to e to the power t. Differentiating both sides with respect to x, we will have dx equals to e to the power t dt. Hence my given integral I will be equal to 1 over t minus 1 over t square, and the value of dx from this equation will be e to the power t into dt. Now again, if you see here, this is my f of x, then this would be my f dash of x, and outside there is e to the power t. So by looking at the type, this can be written as e to the power t into f of t, that is 1 over t plus c as the answer. Now let us put back the value of t. Then e to the power t is x into 1 by t is log of x plus c. Question 6. Integration of log of x plus 1 over log of x whole square dx. So here also let us put log of x equals to t. On doing so, we will have x equals to e to the power t, and differentiating both sides with respect to x, we will have dx equals to e to the power t dt. Therefore my given integral I will be equal to log of t plus 1 over t square. into dx, and the value of dx from here it is e to the power t dt. Now here if you notice that if I consider this log t to be f of x, then the derivative of log t is 1 over t, and which is not present here because the second term here is 1 over t square. So here let us see that the derivative of log t is 1 over t, and if I differentiate 1 over t, then I'll get minus 1 over t square. So here the derivative of log t is 1 over t, and the derivative of 1 over t is minus 1 over t square. So for that purpose, let us add and subtract 1 over t in between log of t and 1 over t square. On doing so, we will have integration of log of t, adding 1 over t and subtracting 1 over t, plus 1 over t square e to the power t dt. Now let us separate the terms, then we will have log of t plus 1 over t. Taking minus common, we will have 1 over t minus 1 over t square, whole thing into e to the power t dt. Now let us open the bracket with e to the power t and multiply to these two terms here. Then we will have this integral as integration of log of t plus 1 over t e to the power t dt minus integration of 1 over t minus 1 over t square into e to the power t dt. On doing so, now you see if log of t is my f of x, then f dash of x will be 1 over t. And here if 1 over t is my f of x, then minus 1 over t square is f dash of x. Hence, we can write this as e to the power t into f of x, that is log of t, minus e to the power t into f of x is 1 over t, plus c. Taking out e to the power t common, then we will have log of t minus 1 over t plus c. Now putting back the value of t, then we had considered log of x equals to t. So e to the power t is x, and log of t is log of x minus 1 over log of x plus c. Question number 7. E to the power 2x plus 1 plus sine 2x over 1 plus cos 2x dx. So this was almost similar to the previous question, but one thing here we have to note that in the power of e there is not only x, there is 2 into x. So for that purpose we have one more formula, that is if integration of e to the power any number kx into k into f of x is there with f dash of x dx, then this can also be written as e to the power kx into f of x plus c. So here we will be using this particular formula. So before that, let us modify the given function. Then we will have e to the power 2x, and in numerator you can see as 1 plus sine 2x can be written as 2 sine x cos x divided by 1 plus cos 2x can be written as 2 cos square of x dx. Let us take out this 1 by 2 as a constant. So 1 by 2 is outside. Integration of e to the power 2x, and let us separate the denominator. Then we will have 1 over cos square x plus 2 sin x cos x by cos square x dx, and here this square and cos x got cancelled, so it equals to integration of e to the power 2x into 1 over cos is sec square x plus 2 sine over cos is tan of x dx. Now this is in the form of this particular type where the value of k is 2 here, and there is k of fx, that is k of tan of x, because as we know that the derivative of tan x is sec square of x. Hence this can be written as 1 by 2 outside, and using the formula we can write this as e to the power kx into fx plus c, that is e to the power 2x into fx is tan x plus c. So this is the answer for this question. So this much in this video. We have completed integration by parts also. In next video we will do some special type of integrals. Till then, practice more and more questions